what we're talking about in section 3.1, you've said, is increasing, decreasing. I'm probing function, but what part of the function is increasing and decreasing? Input or output? Now keep in mind, this happens for all the work in all of mathematics. We get to choose what the inputs are. We're in control. We decide what goes in the function. But what's our question? If I put this in, what's my question? Say it again, Hema. What's the output doing? I mean, if I know what I'm putting into the function, is there any question about what the input is? Yeah, I know because I put it in. I mean, didn't know what I was putting in the function, I probably wouldn't take the bother to put that into the function. So, you know, if I'm putting something into the function, the question always is, wonder what the output is if I take that action. So, back to the question. We're increasing and decreasing the function. What part of the function are we looking at as an increasing or decreasing activity? The outputs. The outputs, yeah, exactly. So, if the function is an increasing function, what's it look like? How can we tell? If the function's increasing, again? Not necessarily. I can have this be an increasing function, and those outputs are not positive. Slope of what? What do you mean by slope of the function? We don't, I mean, algebra 1, you didn't talk about slope of a function. You talked about the slope of a line, okay? So the slope of what line? Any line tangent to the curve, okay. So the slopes of any line tangent to this curve, the slopes are what? Positive values, okay. What's another name for the slopes of the lines positive, or the slopes of the lines tangent to a curve at a point? Another name for that is? Derivative, okay. So if we're talking about where's the function increasing and where's it decreasing, it connects to our work with derivatives, because if I take any tangent and I determine what the slope of that tangent is, if the slope of the tangent's positive, the output values of that curve, of that function, must be increasing as I go through that point. Yeah, that's what we're talking about. Okay, it's exactly what we're talking about. Now, back to that work. If I have a curve that's increasing on this side and then all of a sudden it becomes decreasing, again, which part of the function am I looking at to determine if the function's decreasing? The input values or the output values? The output values. If this function is decreasing, which it looks like it is, and I then say, well, it means that if I take, that's a pretty big point there, if I take any point on that curve, on that side of the curve, and I take a tangent to that point, then the slope of that tangent is negative, then the curve function is decreasing at that point. Okay. If I have something that's increasing on one side and decreasing on the other side, what's going to happen right here? The slope's going to be 0. Very good. I can't remember. Did we do that in this class, or was it the Calc 1 class? We talked about the intermediate value theorem. The intermediate value theorem says this: if I have something that goes from positive to negative, somewhere in here it's got to go through what value? 0. Okay? So if it's going from positive, if the derivatives are going from positive to negative, it's got to go through 0. So the slope right here would be 0. Intermediate value theorem. a value that's intermediate in between two others, and if one's positive and one's negative, it's got to go through 0. It also holds true that if I have an output of 3 and an output of 10, I'm guaranteed that somewhere in here there's an output of 5, because 5 is between 3 and 10. Okay, so it's a nice little theorem there. But anyway, regardless of that, how that relates to this is that how would you identify the occurrence? What's so special about the slope being 0, the tangent being 0 there? What's so special about the point where the tangent is 0? Ryan, again? Yeah, it's called the extrema. We have an extrema there. We don't know if it's maximum or minimum. Maximum or minimum what? Input or output? Maximum or minimum output. Again, everything, if we're always investigating what the output is. Okay, so it's kind of nice that if we go from positive and then negative, that there is an extrema. Now, what if I had over here something that went from negative to positive? Then I would know the function has what? Not a maximum, as I have here, but a minimum. Okay. Whoops. See if I can get that. There we go. Minimum. Okay, now let's see if we can go back to our notes here. Extrema, meaning an extreme point, maximum, minimum, and the first derivative test. Definition of a relative extrema. Let f be a function defined at C. What is C? Input or output? What is C? Input. Thank you. Okay, let a function be defined at C. F of C. F of C. Input or output? Output. Then the output value when the input is C is a relative maximum if there exists an interval from A to B such that C is in that interval and f of x is less than or equal to f of C. Now these get to be sounding pretty complicated. Okay? They really do. All we're saying is that if there is some output that's less than another output, then let me say it this way. If for any input between A and B, this function f of x is less than or equal to that, then f of C is the relative maximum. If all the other inputs on this function, if this is C and this is the point up here, f of C, and all the other inputs of this function are less than f of C, so they're down here, then what's that make C? F of C and f of C, the point up here. And the output value would be a relative maximum output value of the function. That's what it's saying. So this point here is greater than or equal to any other point of the function in that interval. It's a relative minimum if that point, f of C, is less than or equal to any other point in that. So we would have a situation where maybe this is, we'll call this C1, C2 actually. This point right here in the interval, this point right here, its output is less than any other output nearby it. In the old days, back in my Calc 1 days, we had to do a lot of epsilon and delta work. In other words, if there was an input value within an epsilon neighborhood of delta or whatever, it was one of those things that I memorized and never really understood until much later on. But it's just saying that anywhere close by, that's all they had to say. Anywhere close by to this, that output value is less than any other output value nearby. Okay. If that output value is a relative extrema, then the relative extrema is said to occur at that point. Okay, they're just repeating themselves. That's all they're saying. Let's see here. Seems like, okay. Let's see what we have. Occurrence is a relative extrema. If the function has a relative minimum maximum, then C is a critical number. Now I want to highlight that because we're going to talk about critical numbers. Did we talk about that last Thursday? Okay, so you've already heard it before. Critical number. If there's a relative extrema, then it occurs, we call that input value where it occurs to be a critical number. The first derivative is 0 or the first derivative is undefined. Okay. Let's now, a lot of that I was reading from the section 3.1 notes, so now let's go on. Hang on a second, we'll just delete that empty page. There we go. Okay, first derivative test. A lot of this stuff's going to sound like we're just repeating ourselves, which we are. Let C be the only critical number of a function. Okay, C is a critical number. Let's highlight the important numbers here. C is a critical number, which means what happens? It's a critical number because first derivative is 0 or it's undefined. We're going to talk about. The function is continuous. You know what continuity is. No breaks. You can clap, that type of thing. On an open interval containing that critical number. The function is differentiable. Now, if the function is not differentiable, what's it look like? Do you remember? Yeah, you get this real sharp turn. The wrong pin there, don't I? Let's try this again. We get that real sharp turn, such as that. It could be an absolute value, or it could be other things too. Okay, that would be undefined. That'd be one way of being undefined. But if it's not one of those, if it is differentiable on the interval, except possibly at C, because again, it has to be equal to 0 or defined or undefined, then the first derivative, here we go, the first derivative changes from negative to positive. We have a relative minimum. Again, we're not going to say a whole lot different. We're just going to say it in a different way. I'll try not to say it any louder, okay? You know how most parents are. You don't see it the first time, we repeat ourselves and just say it louder the second time. Okay, but that's really basically it. It's the same thing. Now you're writing down like crazy, like this is all worth gold if you have it on your paper. It's really the same thing. First derivative changes from positive to negative. We've got a relative maximum. First derivative does not change. In other words, it goes from negative to negative or positive to positive. Then we have neither a relative minimum or a relative maximum. So we could have a function like this. It's negative on this side and it's negative on this side. But this happens to be a 0 in here. So it comes down and we get what we call one of those inflection points, and the first derivative is 0, but it's not an extrema at all. So we can get some things like that. Okay, so lots and lots of words. You're copying like crazy, which makes me a little bit distressed. So let's just jump to the problems. Again, if you bring in the notes, I have your attention. I know we talked about that early on, but it's getting me more and more critical. Find all relative extrema. Now, relative extrema, I could, let's see, I could try I could try to find some values of the input where the value of the function is, I can't say negative or positive because that doesn't really make any sense. I need to know where they change, where those values will change.